A radioactive sample of uranium-238 decays to lead through a process for which the half-life is 4.5 into 10 to the power 9 years. Find the ratio of the number of nucleus of lead to uranium-238 after a time of 1.5 into 10 to the power 9 years. So if we proceed with this problem, we are considering that uranium-238 is converting into lead following radioactive decay. Now we are considering that at T equals 0, the number of uranium atom is N0, and at a time T equal to T, the value will become N0 minus X. Now the number of the lead nucleus formed will be X. So over here the question is stating that the half-life for this reaction is equal to 4.5 into 10 to the power 9 years. And the question is asking us to calculate the ratio of the number of nuclei of lead to the number of uranium-238, that is N0 minus X. So the question is asking us this ratio after a time of 1.5 into 10 to the power 9 years. So over here it must be kept in mind that whenever we are writing radioactive equations, we use NT as this and N0 as this. So over here if we proceed with this particular problem, I can say that N0 minus X is equal to N0 times of half to the power N, where N can be written as T upon T half. So using this formulation, we first of all calculate the value of N. So for this problem, we get N equals 1.5 into 10 to the power 9 upon 4.5 into 10 to the power 9. That is, we get a value of 1 by 3. So from here, I can say that N0 minus X is equal to N0 times of half to the power 1 by 3. So from this equation I can write N0 upon N0 minus X is equal to 1 upon half to the power 1 by 3, which is equal to 2 to the power 1 by 3, and it is given to us as 1.26. But this is not the correct answer because the question is asking us X upon N0 minus X. So from this expression, we can easily calculate X upon N0 minus X, and it will be obtained as 1.26 minus 1, that is equal to 0.26. So this is going to be the answer for this particular problem. With this we come to an end of the question solving of modern physics.